Okay, guys, so after polynomial division, and you guys have taken the Hawks test number 2, we're going to start with a pretty easy lesson to get you going for the last Hawks test and kind of get on the right track of getting the assignments done. So the fundamental theorem of algebra, we're going to talk about polynomial functions and determine the degree, the y-intercept, whether it crosses or touches the x-axis and stuff like that. So this is what you're going to see on the Hawks. The degree is the highest power of the variable in a polynomial. The multiplicity of a member of a multiset is the number of times it appears in the multiset. For example, the number of times a given polynomial equation has a root at a given point is the multiplicity of that root. So there's some key things that you need to know. If the graph crosses the x-axis and appears almost linear at the intercept, it is a single zero. If the graph touches the x-axis and bounces off the x-axis, it is a zero with an even multiplicity. If the graph crosses the x-axis at 0, it is a 0 with an odd multiplicity. The sum of the multiplicities is the degree n. So we talk about degree being the highest exponent. So you're going to see this on the Hawks. I kind of like to do the first one with you. If I gave you this, x plus 4 squared, x minus 3 cubed, x minus 2. So your degree is the sum of the multiplicities. All right. What that means is I'm just going to add the exponents. So I'm going to take 2 plus 3 plus 1. So my degree of this polynomial is going to be a 6. Now the y-intercept's a little bit harder. What you're going to do is you're going to take the numbers that they give you at the end and their exponents. So we're going to take positive 4 to the second times negative 3 to the third times negative 2, because it's negative 2 to the first, to find your y-intercept. So if I type that in, 16 times 27, which is negative, times 2, which is negative, you get 864. And that's literally what you're going to type in, guys. So it's going to be a coordinate, all right? And it's going to be a y-intercept, so you got to use 0, 864. Now, the x-intercepts at which f crosses the axis, and it tells you right here, if it crosses the x-axis, it's an odd multiplicity. So I'm just looking for any odd exponents. Well, 1 counts as an odd number, so I'm going to use this x minus 3 and x minus 2, and I got 7 equal to 0. So I'm going to add 3, I'm going to add 2. So I get x equals 3 and x equals 2. All right. So our odd x-intercepts would be 3, 0, and 2, 0. Now when it flattens out, we didn't really talk about this one, but anything that flattens out just means that it has an exponent that's greater than 1. So exponent greater than 1 means flattens out. So that would be x plus 4 and x minus 3. And again, you do the same thing. You set them equal to 0 and you solve them. So when it says 0, it just means x-intercepts. So I'm going to get negative 4 and 3. And again, we write them as coordinates. 3, 0, negative 4, 0. And notice 3 shows up twice. That's because it follows both of those rules. It flattens out and it also crosses the x-axis. Okay? And that's really what you're doing on the Hawks. So it's going to be these 4 questions every single time. So I just give you another example. The degree, just add the exponents. So I do 5 plus 1. So my degree is 6. My y-intercept, I would take negative 1 to the 5th times 3, which is going to be negative 3. So right as a coordinate. My x-intercepts, when it crosses, remember it's got to be an odd one. Right? So both of these are odd, because if it doesn't have an exponent, we assume the exponent's a 1. So I would say 1, 0, negative 3, 0. And when it flattens out, it's got to be greater than 1, so that's only one of them. And that's just x minus 1. So then it'd be 1, 0. Again, it's the same 4 questions. You're just doing the same thing, it's just going to give you different problems. So next one, degree. Add the exponents. 3 plus 1, my degree is 4. My y-intercept, I would take 3 times negative 2 to the third, which is negative 24. You write it as a coordinate. X-intercepts when it crosses the x-axis. It's got to be odd. Well, both of these are odd. So I set them equal to 0 and I solve them. And lastly, zeros at which f flattens out. Well, it flattens out when it's greater than 1, so that's only one of them. So type in 2, 0. All right, so that's most of the Hawks. And then occasionally they're going to throw in a problem like this. So it says construct a polynomial function with the following properties. Fifth degree, 4 is a 0, multiplicity 3. Negative 3 is the only other 0. Leading coefficient is 3. So fifth degree means I know my exponents add to 5. All right, 4 is a 0, multiplicity 3. That means I'm going to use opposite signs. So instead of positive form, I use a negative 4. I'm going to raise it to the third power. Negative 3 is the only other 0, so I would take x plus 3. I know my degree has to be 5, so the only other 0 means it's going to have an exponent of 2 because I already had 3. If I take 3 plus 2, that gives me 5. My leading coefficient is 3, so I just put a 3 out front. Next one, construct a polynomial function with the following properties. Fifth degree, so we know it's got to be 5, got to add up to 5. 2 is a 0, multiplicity 2, so I'm going to say x minus 2 raised to the second power. Negative 2 is the only other 0, but it's got to be to the third, and I have a leading coefficient of 4. And that is the fundamental theorem of algebra. So you have to make sure you understand the basics of a polynomial before we move on to rational expressions. All right? Again, certifies 4.4. Make sure you get it done.